Now we are going to talk about the another application layer protocol, that is MQTT. So what is MQTT? It is a message queuing telemetry transport. An MQTT broker acts as a central hub for IoT communication, routing message between client using a publish/subscribe architecture. So this is the block diagram for MQTT broker. So core component of this MQTT broker is MQTT broker, publisher and subscribe, where this broker is the central server managing all data routing, whereas publisher is a edge device sending sensor data to the broker, and subscribes core component is nothing but a client applications or devices receiving request data. Then when we talk about the data flow, so first publish comes into picture, where sensor sends data packets to specific topic on the broker, then subscribes to the client request to receive data from targeted topics, and then bidirectional is the smartphone and PC can both send the communication commands and read the data. So the key benefits of this MQTT broker is it's a lightweight, decoupled and scalable. Then next layer protocol is constraint application protocol, that is COAP. So layer breakdown is first of all the application data, where the top layer containing the actual payload or business logic generated by the IoT application. Then next layer come, that is request or response layer. The upper sub layer of COAP handling the RESTful methods like get, post, PUT and delete along with the status code. Then next layer is COAP messages. The lower sub layer of COAP dealing with the message formatting and reliable transfer like comfortable, non-comfortable, acknowledgement and reset. Then next layer is UDP, that is user datagram protocol. So this underlying transport layer protocol that provides a lightweight connectionless data transfer mechanism. So this is the COAP environment, constraint application protocol environment designed for IoT system using a RESTful architecture. So a REST COAP proxy bridge the gap between the HTTP based internet and the COAP environment, enabling the communication between the two protocols. COAP server manages resources and handle requests within its environment, facilitating machine-to-machine communication among various devices like cameras and clients. So this setup allow constraints devices with limited power and low bandwidth to connect and exchange the data security. So application layer protocol AMQP. So AMQP is Open Standard Application Layer Protocol designed to ensure reliable message transmission and queuing mechanism. The Advanced Message Queuing Protocol AMQP is an open standard application layer for message-oriented middleware. The defining feature of AMQP are message orientation, queuing, routing, reliability and security. This diagram illustrates the AMQP broker architecture, which decoupled message between the procedure and consumer, producer and consumer. So publisher sends message to exchange, which acts as a message router based on the predefined binding rules. Queuing store the message securely until they are processed by a consumer. This model supports various routing types, including direct fan out and topic exchange, allowing for flexible message delivery. So main features are wire level protocol, flexible and secure, and the main application is initially used for transaction message in financial system and now primarily utilizing in IoT applications for communication and data analysis between devices and backend data centers. The next application layer is WebSocket. This WebSocket is a network protocol that provides full duplex communication over a single persistent TCP connection. Unlike HTTP, which follows a request response model, WebSockets enable continuous low latency bidirectional communication between the client and server. This makes them perfect for real-time use cases like live chat application, multiplayer gaming, collaborative document edition, IoT device updating, and financial dashboards. So WebSocket communication starts with the HTTP handshakes. Once the connection is upgraded, it stays open and both the clients and server can push data independently at any time. So step-by-step WebSocket flow is client will send an HTTP upgrade request, then server agree and upgrade to WebSocket protocol, then persistent connection is established. Message can now be sent in either direction with minimal overhead. So key WebSocket properties are persistent connection, low protocol overhead, full duplex communication, operates over TCP. So basically what is WebSocket and how does it works? So you can think of a WebSocket connection as a long-lived bidirectional full duplex communication channel between a web client and a web server. Note the WebSocket connection works on the top of TCP. How does the WebSocket differ from HTTP? So HTTP is a stateless request response model, while WebSocket is a stateful, continuous connection allowing low latency two-way communication. Are WebSockets scalable? So yes, WebSockets are scalable. Companies like Slack, Netflix and Uber uses WebSocket to power real-time features in their apps for millions of end users. So these are the self-learning topics where you can explore the communication protocol more. These are the textbooks which you can refer and these are the online references. Thank you.